The effect of calcium, nitric oxide, cyclic AMP on the smooth muscle contraction and relaxation. Coming to the point, calcium. It is the very element that is responsible to cause the contraction. Coming to the understandings, as the calcium enters through the channel into the cell, so here inside the cell, the Carl modeling is waiting for this calcium. This Carl modeling will combine with the calcium. After the combination, this will form a complex, calcium Carl modeling complex, and this complex is responsible to activate the myosin light chain kinase, which is an enzyme. And this activated myosin light chain kinase, its job is to add the inorganic phosphate on the myosin light chains. Now, what will happen to the myosin light chains when they're phosphorylated? Actually, the myosin will become active, and this activated myosin will then have interaction with the actin. Now, actin, myosin will then interact. After that interaction, what will happen? Contraction will happen. So this is how the calcium is doing the contraction of the smooth muscles. And we have another very interesting enzyme known as phosphatase. This enzyme is actually responsible to cause the relaxation. How? By means of removing this inorganic phosphate. This phosphatase is actually remove the inorganic phosphate from the myosin light chain. Like this, what will happen? The myosin will become inactive. Now this inactive myosin will no longer have any kind of interaction with the actin. So when actin and myosin are not interacting, you can say that they are just going towards relaxation. So like this, the phosphatase is responsible to do the relaxation and the calcium is doing the contraction. Now what is the effect of nitric oxide on the smooth muscles? Nitric oxide is responsible to cause smooth muscle relaxation. Nitric oxide, as it enters the cell, here the guanylyl cyclase is waiting for the nitric oxide. When it is activated by the nitric oxide, it will convert GTP to cyclic GMP. Now this cyclic GMP, its job is to activate the protein kinase G. And now this protein kinase G will send the signal to phosphatase. Now this phosphatase will become activated. You got the concept here, the phosphatase. So now this phosphatase is responsible to dephosphorylate, means that it will remove the phosphate from the myosin light chain. When the phosphate is removed from the myosin light chain, so then the myosin will become inactive. And this inactive myosin will then have no interaction with the actin. So now the interaction between actin and myosin is lost. So you can see that what happened? Relaxation happened. So in short, when nitric oxide enters the cell, it stimulates the guanylyl cyclase, which is converting GTP to cyclic GMP, and this is stimulating the protein kinase G. Protein kinase G is stimulating another enzyme, phosphatase, which is removing the phosphate from the myosin light chain. Then the myosin will become inactive, and inactive myosin is having no interaction with the actin. So then actin myosin will not interact. Then what will happen? Relaxation will happen. So it is actually causing the dephosphorylation of the myosin light chain. In short, in a single sentence, we can say nitric oxide is just doing the dephosphorylation of the myosin light chain. Coming to the next one, cyclic AMP, its action on the smooth muscles. It has got a very interesting way of action. When by means of GS or GI, the adrenalyl cyclase is stimulated, it is supposed to convert ADP to cyclic AMP. This cyclic AMP will stimulate protein kinase A, and protein kinase A, its job is to add the phosphate to the myosin light chain. And here is a bit tricky way. When the phosphate is added into the myosin light chain, this will become sometimes activated, sometimes inactivated. Means that when phosphate is added into myosin light chain, sometimes the myosin will become active due to phosphorylation. Sometimes the myosin will become inactive due to phosphorylation. Now what is the logic behind activation and inactivation? The very logic is that if the adrenalyl cyclase is getting the signal from the GS coupled receptor, then the phosphorylation to the myosin light chain will activate the myosin, then the myosin will interact with the actin and it will cause the contraction. And if the adenylyl cyclase is receiving the signal from the GI coupled receptor, then the adenylyl cyclase, it will cause the phosphorylation of the myosin light chain. This phosphorylation will convert the myosin light chain to an inactive state, means the myosin will become inactive. Now inactive myosin will not interact with the actin, so actin myosin interaction is lost. So like this, what will happen? Relaxation will happen. So in smooth muscles, what is going to happen now? In smooth muscles, increased cyclic AMP will cause the phosphorylation of myosin light chain, and this will cause the inactivation of the myosin. So you can say relaxation will happen. And now this video is about smooth muscles, but in order to give you the understandings about this topic particularly, I will give you another example of the cardiac muscle. So when it is about cardiac muscles, there, if the cyclic AMP is increased, this increased cyclic AMP will add the phosphate into myosin light chain kinase, due to which what will happen? The phosphate will be added to myosin light chain, and this myosin light chain will become then active. You know, active myosin is responsible to interact with actin. So like this, when actin myosin are interacting, they will cause the contraction. So increased cyclic AMP will cause the contraction as well as the relaxation. It is depending upon the signaling. If the signal is received from the GI, it will cause the relaxation. If the signal is received from the GS, it will cause the contraction. So smooth muscles receive the signal of GI, and in the smooth muscles there will be relaxation of the smooth muscle due to cyclic AMP. And in the heart or the myocardial muscle, you can see there will be the contraction or increased inotropic effect of the heart. That is due to because the adenylyl cyclase in the myocardial is receiving the signal by means of the GS. You know, heart is covered by the beta 1 receptor, which is GS in action. Anyhow, if you have information of GS, GI, it's okay. If you're not, we have videos about that. You can search that out in our channel.